Introduction to probability. So let's get some definitions down. Probability is the chance of a random event. An outcome is a single possibility. The sample space, the set of all outcomes, and an event is a collection of outcomes. For example, let's say we're rolling a 5 on a 6-sided die. The sample space is listing out all the options. A 6-sided die has 6 sides, 1, 2, 3, 4, 5, and 6. The event is rolling a 5, and the probability of that, well, there's 1 out of 6, and each of those have the same probability, so 1/6. 1, 2, 3, 4, 5, and 6 are each their own outcome. Now here, 1, 2, 3, 4, 5, and 6 are each separate outcomes, but if we're rolling an odd number, now the event is 1, 3, or 5. So the probability of that event is 3 out of 6. There are 3 options out of 6. And then that can be simplified to 1/2. If we're rolling a 5 or higher, well, that includes 5 and 6. We can take 5 and 6. That's 2 options out of 6, or 1/3. That's the probability of rolling a 5 or higher. So some probability problems require more advanced counting. Combinatorics is the study of counting. So if I'm rolling a sum of 5 on 2 6-sided dice, you might think, oh, well, it's 1 out of 11 because there are 11 possible outcomes, or there are 11 possible events, and they're all equal. Well, that's not the case. If you look at this, the whole thing here is the sample space. I could roll 1, 2, 3, 4, 5, or 6 on both of the dice. So really, there are 36 possible outcomes. 6 this way, 6 this way. We multiply the 2 together to get a total of 36 possibilities. Now, how do we get a sum of 5? So that's 4 and 1, 3 and 2, 2 and 3, and 1 and 4. So really, there are 4 ways to get a 5 out of the 36 possibilities, which is a probability of 1/9. You'll notice that they're not all equally represented. What sum is the most likely to happen? Well, 7 appears all along this diagonal, and its probability, well, there are 6 options out of the total sample space is 36, and that gets simplified to 1/6. Probability of 7, the probability of rolling a 7, is 1/6. What sum is least likely to happen? Well, there are 2 numbers here that only appear once, and that's a 2 and a 12. So the probability of 2 is 1 out of 36. It's also the same as the probability of rolling a 12. That notation just means the probability of this event. I showed that here. Probability of event A was 1/6. Theoretical probability is what we've been looking at so far, probability based on the event size divided by the sample space size. Whereas experimental probability is probably based on an experiment, taking the number of successful trials and dividing by the number of trials. So if you didn't know what the die looked like, if you were trying to figure out whether it was a fair die or not, you could roll a bunch of times and say, okay, I got a 5 28 times, and out of, 300 rolls. Now, is this a fair die? Yeah, probably, because that's pretty close to 1/9. But that's experimental probability. Experimental probability will change from time to time, whereas theoretical probability is the same. Lastly, compound events are when the set of outcomes can be subdivided. And we split those into independent events and dependent events. Independent, meaning that it doesn't depend. So one outcome doesn't affect future probabilities. Dependent events is when the result of one outcome does affect future probabilities. So that's how we split up probability.